Hello, everyone, and welcome back to the Cloudology stream. So today, what I've got in store for you is a very basic introduction into Terraform, what it is, and how to use it. And we're actually going to look at some code and provision a compute instance in Google Cloud Platform, since that is my favorite cloud platform. All you Google haters can suck it. um, or all you Amazon people can suck it, I should say. But we're going to provision it on there. So, with that being said, we're going to dive into basically like a quick overview of what Terraform is. Now, if you watched my previous video on top 10 tools in cloud, you notice Terraform was one of the first ones I talked about, if not the first one I talked about. So Terraform is basically a tool that is used to provision resources in a cloud environment, right? So essentially, without actually manually clicking through the console, minus one step that I'm going to show you in a little bit to create a service account, you don't have to do that, and you can reuse that code and provision more resources with it in certain ways. I'm not going to get too involved into the reusing part of it. Using Terraform modules and stuff. I'm going to do a more in-depth, a more advanced Terraform tutorial a little bit down the line. I need a little bit more prep time for that. And it's probably going to be a longer video, and it might be a pre-record. I was actually going to do today as a pre-recorded video, but I didn't have time to pre-record it, so we're just going to go ahead and do it live. So I have a Google Cloud project right now that I'm going to share with you. Basically, this is just a project I literally just created right now, and it is a Terraform Basics 12. So Google Cloud projects have to be unique because all of them are unique. So it uses the ID across all of Google Cloud. So every project ID has to be unique. Amazon does the same thing, except they have like a really long string of numbers where you can kind of pick your name when it comes to Google Cloud. And what up to Sam Prashansky says, chat it up. Yes, feel free to put any questions in the chat. And Tech Chief here says he's cooming. So that's good information for tonight. So we're gonna keep that in mind. So the first thing we need to do here is we need to create a service account that can basically act as Terraform for us, right? So what we're going to do is we're going to come to the Google Cloud Console under your project, whatever project you decide to create, and we're going to create a service account, right? So for the service account name, we're just going to give it a name called Terraform Access. And the service account ID is going to kind of auto-populate, and this is going to be the email address that you're going to basically identify it as. So Google Cloud works with every service account or IAM works off of an email address versus the way Amazon does it, which I'll get into in a different video. And a description, this is just a service account for or to access GCP compute. Compute. I swear I can spell. Okay. So create and continue. Grant access. All right. So we're going to select a role. So typically this isn't the best way to do it. I believe with Terraform, you want to restrict a little bit of the permissions, but for time's sake and for simplicity's sake, I'm going to give it compute engine admin access. Compute engine. I don't think we want service agent. We want compute. Oh, this is excellent. You get to watch me click through the console. Probably the most exciting thing that you have ever witnessed. I actually don't use the console very much, so this is a little bit different for me. I'm used to just doing this in code completely. So compute engine, there we go. Compute admin. That is the role I want to give it. So we give it compute admin because basically this gives it all of the permissions necessary to do everything with compute engine. So it allows us firewall permissions. It allows us, destroying and creating new compute instances, and pretty much anything we need to to interact with the compute API, the compute Google Compute Engine API, essentially. And so now we need to get a key for this. So we can do manage keys. We need to add a key. We need to create a new key. And this is going to be a JSON key. And essentially, this is kind of like an SSH key for Amazon, which is you need this JSON file locally to be able to access your instance. Otherwise, you're not going to be Terraform's not going to be able to access your actual account. So we're going to go ahead and create Terraform access key. You can see it downloaded it to my file down here, which I'm going to throw that in our VS Code project. I do not want to install Xcode, so we're not going to do that. Xcode is terrible, but by the way, it's probably not terrible. I just don't know how to use it very well. So what we're going to do, I'm going to open my Finder, and I'm going to open it over here so you guys can't see it. Sorry. But we're going to put this Terraform basics in the root directory of this project. My private key's on the internet. That's cool. Don't really care about that for right now because all this is going to get destroyed after this video is over. I'm going to add a .git ignore, even though this is not going to get. Just because I'm paranoid like that. And we're going to ignore any JSON files, which hopefully that works, but it's not initialized as a Git module or a Git repository. So there. So there's my private key, all for the internet to see. So that's cool. So now what we're going to do is we're going to create some of the base layout we need for actually connecting to Google Cloud Platform, right? And I wonder if I have my G Cloud stuff set up. Anyway, I digress. So the first thing we're going to create is a providers or provider file, Terraform file. So all Terraform files are appended with the .tf .tf file name, which basically identifies it as a Terraform file. So Terraform can recognize anything that is a .tf file, basically. And so the first thing we need to do is we need to identify what provider we're using. So what cloud provider we're using. Obviously, we're using Google. So we're going to put that here, and thank you, autocomplete, because it's awesome. So we have to give the provider credentials to actually connect to. So we're going to say credentials, and we're going to give it a file. We're going to give it that JSON file that's right there in our root directory of our project. So we're going to we're going to use kind of like an injection or like a function. I believe it's called a function in Terraform or an HCL markup language. So we're going to designate a file, and it's just called, actually that name is ridiculous. So I'm actually going to rename this because I don't want to type all of that out. So we're just going to rename this to creds. So this can basically see that file creds .json. So essentially, it's just going to load this JSON file, which is our Google service account credentials. That way, it has access to actually build stuff on our profile, right? We're going to denote our project. Typically, you would want to put this in like some type of variable, because if not, it's just going to look really ugly, and it's not really best practice to put all your information out there. But I digress. This is good enough for this tutorial. Terraform basics -12. So that is our project ID / project name. I named them the same just because it simplifies things down the line. We're going to give it a region. And I'm going to do US Central 1 because I like US Central 1. All right, so that's pretty much it for the provider side of the house. So let me talk through this really quick. I know I kind of glanced over a lot of this stuff. Again, the provider block in HCL basically identifies what cloud provider you're going to use. So that could be AWS if you're working on Amazon. It could be Microsoft, Azure. I forget the actual provider name. If you're working with Microsoft, Azure, unfortunately for you, if you are. So that provider can be whatever cloud platform you want it to be. The credentials look a little bit different for AWS and Azure as well. So this is specific for GCP. I can do other tutorials for other cloud platforms, but honestly, they're pretty much all the same. It's just they're called different things. So, for example, this wouldn't be Google if this was AWS, right? This would be AWS. But for this specific tutorial, this is for Google. And essentially, like I said, we remember that JSON file we downloaded from Google Cloud for our service account, and we put it right here in our root directory, which is terrible practice. Don't ever do that. But for this tutorial, it will suffice. So that essentially is just authenticating us with our project as that service account. So it can create things in Compute Engine. Remember, that's the role we gave it. Back here, this Terraform access role, because it has the GCP compute instance role, right? And then you have to select your project. So this is just your project ID, which you can find up here, along with my list of other projects that I have in my account currently. And then we also have the region you're going to be operating out of. So cloud platforms typically operate in regions. So you can have US East 1, US Central 1, Asia Central 1, or whatever, other parts of the world have their regions in. Typically, I work out of US Central 1 because I'm closest to the central region. I don't know if that actually makes a difference, to be honest with you. I'm sure it does on some, millisecond level when it comes to response time and stuff like that. So that's essentially what we're doing. We're just identifying, hey, I want to build on Google. Here are the credentials for it. Here's the region I want to build in. That's what this providers file is doing. Next, we're going to have another file called, we're going to call it, we're just going to call it instance.tf. And essentially, this is going to be where we put everything relating to our Google Compute instance, right? So we want to create a Google Compute instance, which is basically a compute engine, right? Is what Google calls it. It's just if you're familiar with AWS, it's just an EC2 instance essentially. So we're going to define that in this file. But before we do that, yes, Tech Chief, Klaus platforms, maybe potentially in the future. Is it not all? Are they not all Klaus platforms? In reality, they probably are. For those of you who don't know who Klaus is, you should subscribe to Tech Chief's channel and find out, because he does many videos on Klaus and has many videos on Klaus. So the first thing we need to do is we need to tell Terraform that we want to provision a resource, right? So we're going to use the resource keyword. Resource. So this resource is going to be, you can see my autocomplete come up. Give me a bunch of Google commands because my IntelliSense is smart enough to know that, oh, this guy is using Google as a provider, so therefore he's probably going to want some of the Google resources that are available. Unfortunately, it does not give any of the ones I want right now. What we're actually looking for is Google Compute Instance, and we're going to give it a name of, we're just going to call it default because we're defaulting on stuff today. But we do need to give it a name, and we can call it super cool virtual machine. So that's going to be our VM name. The machine type. So machine type is, I'm probably going to have another video on this specifically because there's different sizes um, of virtual machines based off of like how much compute power you want, or how much memory you want, or even how much like disk space, or whatever the case may be, how much you actually need. So I think the smallest instance Google has is it's called an F1 micro, which is like, I think it's like maybe like a gig of RAM. I'm not sure. It's really small, super tiny, and it's typically in the free tier because I'm a cheap bastard and we're going to use the free tier. So also, we need to identify what zone this is going to be in. So zones in Google, it is like the subsection of region, right? So you have your region, which is the overall arching area where you're going to deploy your stuff, and then you have a zone, which is like one specific, I guess, like data center within that region. So typically, it's going to be the same naming convention as the region. So it's going to be US Central 1. And it's usually appended with like an A or a B. So we're just going to go um, A for right now because I know that exists for sure. So if you pick one that doesn't exist, it's going to tell you. It's going to give you an error. I think there's A, B. I think there's A, B, C, D, and F for Central, if I remember correctly off the top of my head. You can always look this stuff up. Google has pretty decent documentation when it comes to provisioning stuff, right? So next, we need to give it what's called a boot disk, which essentially is just um, the hard drive or image it's going to be built off of, right? So we can give it an initialize params, and we need to give it an image type. And the image I have in my notes here is just going to be a Debian image, which is a Linux distribution. Debian Cloud. We know Debian 9. I think that's relatively new. So essentially, we're just telling, hey, this compute image is going to be, or this VM instance is going to be a Debian image, and it's going to be based off of Debian 9, right? So it's just a Linux distribution. Not trying to get too much into distributions. We need to give it a network interface. So network interface, and we're just going to give it a default network. Network equals default. So network interface is just the actual connection to the rest of the internet, basically. And we also want to give this an access config, but it's going to be empty because we want this to have an external IP address so we can actually get to it from our local computer, right? All right, so I'm also going to give this a startup script, right? So what's cool about Terraform is if you just want to deploy this and have it automatically run your app, as long as your app is well developed, you can actually do that by giving it some metadata. So you want to do a metadata startup script right there in my IntelliSense, and I'm just going to give it a command that I have in my notes over here. So I'm going to throw this in here, and then I'll kind of explain what it is. I think I already have that in string format. Yeah, I do. Okay, so essentially all this is going to do is going to perform an update on the Linux instance with this, and then it's going to install Apache 2, and it's going to force yes. So whenever you install something on Linux, it asks if you actually want to install it, yes or no. So this is an automation step you want to do, because if not, your metadata script is just gonna it's just gonna get paused right there, and you're not actually gonna install anything. And then here, basically, all we're doing is creating like a really simple HTML file that says, "Welcome to your really elaborate cloud-hosted application," and then we're going to basically just host it as this right here. I don't remember what T stands for off the top of my head. I'm not super great at Linux. I would have to Google that. I always Google my Linux commands because I remember very few commands here and there that I just use on a daily basis. Um, so we can also give this some. Oh, we need to give it. Let's give it a tag too. Give it some tags. Tags always have to be a list. You don't have to have more than one, so you can just have one. We'll just call this HTTP server, right? And that's going to be pretty much it for our compute instance. So just a general overview of what we did here. We gave our machine a name. We gave it what type of machine we want, which there's a list of machine types on Google's cloud platform or Google documentation somewhere, and then we identified a zone where we want to put everything. It's going to be a Debian image, so just a Linux distro image. Just going to be a Linux machine, and then we're just attaching it to the default network interface. And again, this is just to make sure I can actually put some comments in here. Need this in order to get public facing IP address. We're just going to put that in there so we know what that's for. This metadata script is just creating a real simple HTML page, and then we're giving it some tags just so it's easily identifiable and selectable by other services, by specifically our firewall. So, which we're actually going to get into that right now. So, normally, the way you would do this is you would put your firewall rules in a different file, but to condense everything into this one file and make it a little bit easier to read for someone who's not very well versed in Terraform or the cloud in general, I'm going to keep everything in one file. Typically, like I said, you would absolutely want to separate all this stuff out, so that way you can go to one spot and like all of your stuff for firewall is right here, or all of your stuff for IAM permissions is right here, and all of your stuff for instances is right here, and so on and so forth. So we're going to need a firewall resource to actually make our VM instance accessible to the internet, right? So we're going to need another resource, and it's going to be a Google Compute Firewall. And we're just going to give it a name of our tag up there, HTTP server. So we're going to give this firewall rule a name. And I'm just going to call it just the default. We'll call it allow HTTP Terraform, right? And we're going to attach it to the default network. And then we have to set our rules for the firewall. So we're going to allow TCP protocol. And we're going to give it a port, which is, we're going to use the HTTP port, which is 80. So that's basically going to allow traffic to HTTP via TCP. And I know that's a lot of acronyms that I haven't explained, but so when you visit a website and it says HTTPS, https://streamyard.com or youtube.com or whatever the case may be. So HTTPS means it has a certificate and it's a secure site and it runs on port 443, which is a secure port to actually connect to. HTTP, however, it has no certs, and it's technically an insecure port, but a lot of communication layers still communicate on there. Stuff that's not filled with sensitive data needs to communicate, and that's just an easy way to do it without getting certificates and all that stuff. So we need to give it some ranges too, because by default it doesn't know any ranges to give it. So what IP addresses can actually access this? So we're going to do source ranges, and we're just going to do we're going to open this up to the world. So the world will be able to access our instance, right? Which is terrible practice unless it's actually an application you're running. But even then, you still want to have that application like behind a load balancer. So the load balancer should have the public IP in best practices, and then send traffic from that load balancer that hits that load balancer to the VM instance and to your application, right? But for simplicity's sake, we're just going to open it to the world, and hopefully someone hacks us in the middle of this live stream to make it a little bit more interesting. So we're also going to target certain tags, right? And we're going to target the HTTP server tag. So it associates this firewall rule with this VM instance that we defined up here. So we tag this VM instance with HTTP server. So it's going to associate this rule with that server. And we're actually going to give an output as well. That way we have the IP when all this stuff is built. So we're just going to give it IP address, and the output value is going to be so we got to use this string. I think this is outdated. I don't think you have to do this anymore. Google compute instance default network interface .0 access config .0 NAT IP. All right. Now, what the hell did I just type there, right? So when you want to get other values from resources to use in other parts of your code for Terraform, you're going to have to address, or you're going to have to target them using basically like object notation, right? So we're going to target a Google Compute instance, which, look at this, a Google Compute instance we have right here, with the name of default. So default is right here. So we're going to target this Google Compute instance that has the name of default, and we're going to access the network interface, which is right here, which we gave it, called default, or at 0. Sorry. So network interface is an array. So we need to access the first element in that array, and we need to basically get access config, right? Let me make sure that's actually correct. So this access config actually has to go inside network interface. I just realized that. Oops, wrong button. I was wondering why that 0 was there. It actually made me think about it a little bit. But that's good, because what we do is we think. We think as software engineers / cloud engineers, right? Okay, so this is what the 0 is essentially. It's the only element we have in network interface right now other than the actual network. So we need to access this. And access config at 0, we're not giving it any specific, like we're not giving it a static IP address. So it's just going to automatically assign a NAT IP to it, right? So this will output the IP address after we build it, so that way we can actually access it. And okay, so I think we should be good to go. Let me save this file. Let me go back to provider and make sure it's saved. So now we're actually going to test to see if what I did is correct. the first thing we have to do for Terraform is we have to initialize Terraform, which means it's going to reach out and grab this provider and basically verify that it can connect to our Google Cloud project, right? So we're going to do we're going to run Terraform init, which is just a Terraform initialization essentially, and it's going to download our state file or our lock file, which is right here. Typically, you want to git ignore this as well. You don't really want to have these files committed to Git. One, you don't really need it other than locally, and ideally, you should be storing state, in like a GCS container or S3 bucket if you're using Amazon, right? So now let's see if what we did is actually correct. So Terraform init, like I said, is just initializing Terraform to tell it, hey, we want you to use this provider, and here's the stuff, for our account that we're going to give you. Now go out and get it, right? So now we're going to run Terraform plan, and we're going to see this basically checks to make sure that our infrastructure is formatted correctly. So we're going to run Terraform plan. An argument port is not expected here. So this also tells you if there's any error. So ports with an S, because this is a list, right? So we need to have at least one. So it's expecting a list. Line 31. Yeah, that was the right one. So we're going to run that again. All right, cool. So let's look at our output here for Terraform plan. So this is the cool part about Terraform is it tells you exactly what it's going to make before it even makes it. So it's going to create this firewall rule, this HTTP server firewall. It's going to name it exactly what we named it. It's going to use a default network, default priority, and our ranges. Here are our tags, the ports we want to allow, and the protocol we want to allow, right? So it shows us what it's going to create before it even creates it. And then it's going to create this compute instance, and it's going to run this metadata startup script. It's going to give us our machine type, and all this stuff is going to be known after the apply. And here's our name that we gave it. Here's the zone that we're going to apply it in. The tags that we named it. Here's our image, Debian image, enable confidential compute. Yep. So all this stuff is going to be created in the cloud. It's not created yet, but it will be created after we run this next command, which is Terraform apply. At least it should be, as long as everything is correct. Okay. So even if you run Terraform apply, it's still going to ask you, hey, are you sure you want to build this stuff? Because, granted, we're only making two things, right? So it's not a lot of stuff. It's not a big deal if we create it and we're like, oh, we screwed it up, so let's delete it and recreate it. Yes, but what if you're working on an enterprise level application you're building infrastructure for, and you're provisioning like hundreds of resources? You know what I mean? It would be really annoying to have to delete those resources and reprovision them all over again, even though you can avoid that. But it basically makes very sure that you actually want to do this, because this costs money. So the more resources you have, the more money it's going to cost, and the more stuff it's doing, the more money it's going to cost, right? General rule of thumb. You can actually go into a price calculator if you really want to know about it. But we're going to type yes, and of course we get an error. 403, Compute Engine API has not been used in project. Okay. Or is disabled. So basically what we need to do is we need to enable the Compute Engine API, which is not enabled on this project specifically, so we have to enable it. So basically we have to tell Google that, hey, we want to use your API to like build shit. So we have to enable it for this project. Let's make sure, what other error do we have? It's probably all of them. API has not been used in project. Yep. So yeah, just a Compute Engine errors, which I should have known, but I forgot about it. So basically we have to wait until this API comes up. Usually it's pretty quick. Of course, now it's going to prove me wrong. It's going to take all year to do. So in the meantime, excuse me. Excellent. Of course, this is going to take forever. Normally, this doesn't take that long. So if there's anyone in the chat that has any questions, which there's not many viewers, so I'm assuming it's going to be a no. But I digress. So I can genuinely go over or generally go over what we did yet again. Oh, another thing I want to mention is Terraform State, right? So Terraform State is essentially it is a list of resources that's already provisioned. So Terraform keeps track of what is created and destroyed with Terraform with the state file, right? And without that state file, Terraform kind of does. You can like pull state. There are tools to help you pull state for existing resources and stuff like that. But generally, you don't want to get rid of a state file. You want to store it somewhere pretty secure so you don't lose that. So nothing like you know gets lost in translation or anything like that. So state, just think of it as like Terraform keeping track of what it's created for you and what has been destroyed. So this is how so let's say we apply this, right? And we say, "Oh, we want to get rid of the firewall rule or we want to change it." Well, how does Terraform know like what needs to be changed? Obviously, it has to know what's already there, right? Well, that's where the state file comes into play. So it sees like, "Hey, this is our current rules. We're going to compare it with the new state that wants to be, applied, and we're going to make those changes to the state and kind of like merge them together." All right, so now we have our Compute Engine API up and running. So we should be able to run Terraform apply again and give it a yes, and it should work now, unless I have more errors, which is possible. So yeah, you can see it's creating our firewall and it's creating our instance. Hopefully it won't error out and give me more problems. Of course it does. Could not find image or image family, Debian Cloud, Debian 9. Okay, so that means it couldn't find the image we're trying to look for. So let's look for some images. That might be out of date, to be honest. So let's do Debian 10. Let's do Debian 10. Nope. Debian 10. So can we family Debian 10 Buster. Interesting. All right, so we're just gonna do this. We're gonna do Google Compute Debian images, public images. Let's run this G Cloud Compute Images list. Let's do that. Let's not look at my notes. So let's do G Cloud Compute Images list, and we're gonna pick an image from here. G Cloud. Oh my, yes, sir. Please enable that API. So that's kind of the annoying thing about Google is you have to basically any service that you want to use, you have to enable it, which I mean is good for a billing perspective, so you don't get charged for stuff that you're not using. So it's kind of cool, but when you're just trying to like turn and burn on a project, it's kind of annoying. I don't think anybody goes through and provisions is like, oh, we need to turn on all these APIs. They just get an error and they're like, oh, I gotta turn that on. So hopefully that doesn't take forever. Probably take about as long as the last one. You can see here the Terraform state also makes a backup file. That way it just, in case one gets lost, it has, one to make a copy out of, right? So that's, state is a big deal when it comes to Terraform, right? Because if you don't have the state, then you don't have your resources, and your code is going to be completely screwed up. Or maybe you have people, creating instances outside of Terraform, which kind of like screws up some stuff too. So that's kind of annoying. All right, so wow, that is a lot of images. So we got CentOS, Debian 10. Let's do that. Debian Cloud. Let's rename it. Debian Cloud, Debian 10. So I guess Debian 9 is probably end of life now. So that's cool. So yeah, we're just going to use Debian 10 right here. So Debian Cloud / Debian 10, and that should work. So we're going to reapply and do not capitalize. We're just going to hit up. There we go. Terraform apply. Oh, this just needs to make the IP instance basically because it tried to make it on an instance that it doesn't have access to anymore. So ideally, it should make it with Debian 10 instance now. Let's see. Let's see if what I did was actually correct. This is part of the fun of being a cloud engineer, is waiting for your stuff to be created. You know, sometimes it could take like up to an hour. Boom, apply complete. 1 added, 0 changed, 0 destroyed, and output. And boom, here we have a public IP address, right? So let's go back to our VM instances, and whoa, look at this. Look at what we have here. We have our very own virtual machine with an IP address right here. Super cool virtual machine that happens to be exactly what we named it right here. So here's our super cool virtual machine. Let's see if we can actually look at that. Look at that. We have an application in the cloud right now, as denoted by the screen. Welcome to your really elaborate cloud-hosted application. Congratulations. Y'all just hosted your first application on Google Cloud Platform, if you are watching this and doing it live. So yeah, that's pretty much how Terraform works. One last thing I'm going to show you guys before I end the video, because this video went much longer than I intended it to, but that's fine. So you have all these resources provisioned out, right? So now what do? Let's say we want to get rid of this and we don't get charged for it. Our project's over. You know, the testing we were doing is done. Well, again, that's where our good friend Terraform comes into play and gives us a command to destroy all this stuff, right? So we type Terraform destroy into the command line, and essentially what it's going to do is it's going to look at our state file and be like, hey, here's some resources. We're going to get rid of everything in this state that is denoted, right? So everything that is here is going to be deleted, basically. And you can even see it tells you exactly what it's going to change and what it's going to delete before it actually does it. So there's no plan for delete. There's no Terraform plan for delete. That's only for applying resources. But if you want to destroy stuff, this is how you do it. So we're going to type Terraform destroy. It's going to ask us if we really want to do it. We're going to say yes, absolutely. We want to destroy all of our stuff. And once this is complete, I'll show you that all of our stuff is gone. Our firewall is gone and our instance is gone. I didn't show you the firewall after it was up. Unfortunately, I forgot about that. But no problem. I think we can still see it if it's deleted, if I remember correctly. All right, 2 destroyed. So if we refresh this, we can see we have no more instances. So we deleted all of our instances. Let's check our firewall rules. These are just default Google rules. We don't have any of ours anymore. No rows to display. It's all gone, right? Let's go back to Compute Engine. Storage, instance groups. Yeah, that's pretty much it. We created an instance, we had an application running on the cloud, and then we destroyed it. So that is the use case for Terraform. And I know if some of you are new to cloud or new to infrastructure, this probably went a little bit over your head. I get it. I understand. This went over my head too when I was watching similar tutorials like this when I first started this. But the more you start using this kind of stuff, the more it's going to kind of like become second nature to you. So if you have applications already that you've made, try deploying them with Terraform. Like you already know the application works, right? Because you're developing it locally, even if it's something simple like a to-do list. Do your research on Terraform, create a compute instance in Google, give it some firewall rules, and give it the metadata script here that actually starts your application, right? So you can create a bash script that runs like an npm run start dash dash prod. You know what I mean? So you can use Node to provision your app and stuff like that. It doesn't have to be like all Linux commands. This was just to simplify it and to kind of show you guys what's going on. So that essentially would be like a script you use to start your application, which is why it's called a startup script. So after the VM is provisioned, it calls this script that runs your application. So, and then if you follow these same rules, you should be able to reach it with the public IP address that Terraform spits out for you. So if you're a developer and you're making your own applications, I highly, highly, highly encourage you to play around with Terraform because it's just a cool thing to know. Like, even if you don't fully understand like how it's working in the back end, that's not the important part. The important part is it accomplishes what you're trying to accomplish yourself, right? So if you're trying to deploy your application, imagine you're a software developer applying for a job interview and you're like, yeah, I deployed it and I used Terraform to deploy it completely by myself. You know what I mean? Like, that's pretty good because most developers will just run on like, Heroku or like, I don't know, Elastic Beanstalk on AWS, or maybe even Cloud Run if they're familiar with Docker containers on Google. Now imagine you provisioned your own infrastructure and then hosted your app on it with code. Like, that's got to look really good as a developer. Be like, okay, well, this guy obviously understands some infrastructure, so you can kind of leverage that in your job search if you're looking for a job, or just to further your knowledge and understanding how some of this development stuff works and how applications are deployed on the cloud and stuff like that. Because it's a lot of buzzwords that recruiters love to hear, and will get you in front of the people that you need to talk to. And if you're not a developer, if you're just getting into cloud and you want to get directly into cloud, you need to learn this tool. You have to learn Terraform. I have not worked at a place that hasn't used Terraform yet. It's kind of the industry standard right now. It's not the perfect solution, I'll admit. There's some issues with it. I mean, this is version 1.0. Like, the industry is using this before it was even fully like versioned out. So yeah, I mean, it really would benefit you to learn Terraform, whether you're just trying to get into cloud or you're a developer, because this is the industry standard, guys. Like, I don't think Terraform is going away anytime soon. I'm sure there are a bunch of clickbait videos out there, be like the death of Terraform, and it shows some other really cool tool. There are other options out there. This is just the one that I know and that I've used and that I'm really familiar with. So with that being said, I really do hope this gave you a good overview of like how provisioning with code actually works versus like clicking through the console like we did to set up the service account initially. So with that being said, I'm going to end this video. I hope that this was informative to you guys. I want to make another Terraform video that's a lot more in depth. So stay tuned for that, and that's going to get into the more advanced side. So I might lose a little bit of the newer people to IT and cloud and even development, because I'm going to get into a bunch of like really cool stuff you can do with Terraform. But yeah, with that being said, hope you guys have a good night. Thanks for watching, for those of you that watched, and I will see you next week.